All right, so next we're going to work on the properties of congruent and similar polygons. And first we're going to identify the difference between a convex and a concave polygon. And I've given you a couple of images. The concave polygon, we don't see them very often, but those are the ones that are, they have like an inward side. Okay, some other things that we need to know about this section are the differences between equilateral isosceles and scalene triangles. An equilateral is always going to have 60-degree angles inside. An isosceles triangle has two equal sides and the base angles are equal. And for a scalene, there's no equal sides and no equal angles. The other thing that we need to remember about this section is our special centers of triangles, and we did something with this in GeoGebra through the course. The centroid is made up of the intersection point of the midpoints, which is the midpoint, the median rather. That makes the centroid. The circumcenter is the perpendicular bisectors. So again, you see that they are those lines are perpendicular to the side, and the side is bisected by that line. The incenter is made up of angle bisectors, and all three of these meet at the same point. So I just want you to remember those, and I'm wondering if I left off orthocenter. Let's see. Okay, I thought I had maybe left off the orthocenter, but here it is at the bottom. It just got misplaced. So here's the orthocenter. That's made up of the altitudes, and so those are your four centers. Now in our first sample question, we are asked to find whether point D is a centroid, circumcenter, incenter, or orthocenter. And since we are given information about the angles, it makes me wonder if this is going to be an angle bisector type of situation. What I do know about this is that all of those angles inside are going to add up to 180 degrees. So basically this angle plus this angle plus this angle all equal 180. And we have a lot of information about that. We have 6x minus 4 and 20, or 2x plus 20, that makes up the top angle. The bottom right angle is 10x minus 22, 6x plus 2, and then the bottom left angle is 2x plus 8 and 3x plus 2. So basically I'm going to add them all up and find out, set them equal to 80, so let me add them. And for the x's, I get 29x, and for the constants, I get plus 6. So now I have all of the sum of the interior angles. 29x plus 6 equals 180. And I'm going to solve this equation. And I get x equals 6. So I still am not quite there, but I'm going to look at these, I'm going to plug them in and see what these values are. So if I plug it into the 6x minus 4, which is the top angle, that's going to give me 36 minus 4, which is 32. 2 times 6 is, for the second one, 2 times 6 is 12, plus 20 is also 32. So this is an angle bisector. I'm going to check the other pairs as well. Plugging in my 6 for the second pair, I get 38 for both of them, so that's also angle bisector. And for my last pair, I also get equal angles, and 20 and 20, so those are angle bisectors. So now I just have to remember that the angle bisector forms the incenter. So the answer to this question is the incenter. That's the angle bisector one. So just make sure that you memorize the 4 different types, and that way you can work these types of problems. I'm pretty sure there will be one like this on there. Okay, for our second question in this series, we have some similarity, and I know that it's similar because the sides are parallel. So the three lines that form First Avenue, Second Avenue, and Third Avenue are parallel. That automatically creates some similar triangles. So I have this top little triangle here that is similar to the larger triangle that is formed by both of them, is similar to the ginormous triangle that makes up all three. Remember that with similarity, we are looking for proportionality, so that's how we're going to solve this problem. Okay, so there's more than one way to solve this problem, but in looking at it, I think I'm going to start with the little triangle on the top and try to find its base. So I'm really looking for this section right here. I'm going to try to solve that and figure out what that is. So that'll be my x. So I'm going to do 118 over x. That's the side of the little triangle over the base. And that's equal to the side of the middle sized triangle, which is, here's its side. Its side has a total of 300 meters, and its base is 406. So to solve this, I'm going to cross multiply. This is 300, looks like 800. I'm going to cross multiply. So here I'm going to get 300x is equal to 47,908, and I divide both sides by 300, and I get x is equal to 159.7. So that's this distance. Now in the problem, I think it was probably better that I had explained this to begin with, but we're talking about she drives from point A to point B, so let me grab a different color here. Let's use purple. She drives from point A to point B, and then from B to C. And so the question is, how far did she actually go? So I need to find a couple of things. I need to find the distance between B and C, and also this distance here from A to that next intersection at 2nd Avenue. So I can do that by setting up a proportion. I can find the little squiggly piece by setting up a proportion this way. 118 over x equals 120 over 180, using the proportionality of that triangle. And I'll cross multiply. And I get 21,240. So x is equal to 177. So that gives me a piece of it. Now the only other piece that I need to find is the piece that is the side that is BC. And so I'm going to use my little triangle, which is 118 over 159.7, because that 159.7 corresponds to BC. And then I'm going to use the big triangle, which over here has a total sum of 495 is that total length. So that's 495 over BC, and I cross multiply here. And divide by 118. So I get 669.9. Now to answer my final question, which was how far did she travel, I know that she traveled 177 plus 200 plus 669. And I get, yeah, that makes sense. Okay, I get 1,046.9, but I'm going to the nearest seventh, or nearest whole number, so I'm going to round that up to 7. So that's my answer, 1,047. All right, next we're going to look at transformations, and I put the information in here about what happens to the coordinates when you do a transformation. And we've done things with line reflections, and we figured out why, or we thought about why your coordinates x, y, when reflected in the x-axis, negate the y, because you're really kind of changing the y value, not the x value. And same kind of idea with the y-axis. When you reflect in the y-axis, you're changing the x value, but the y value stays constant. When you reflect in that line y equals x, which is the identity function, you're really just interchanging the two coordinates. And then we didn't really talk about this one, but I added it in here anyway, just in case it happens to pop up on the test. Basically, if you're reflecting in the negation of the identity function, y equals negative x, you interchange them still, but you negate both points. So we also talked about, well, we didn't really talk about point reflections so much, but that information is there for you. I think what's going to be important is the rotations, because I think that's the hardest one to visualize. I think these are the ones where you're going to need to really memorize these ideas. And for the dilations, as you know, you have your scale factor. In this case, they're calling the scale factor k. And that just really multiplies each coordinate by k. And then for translations, you're going to add or subtract from each coordinate to get to the new point. And we practiced that on Friday, I think it was. So here's our first sample question. And it has to do also with similarity. And that's how they're going to make these questions be, is that you're always kind of trying also to think about the similarity of it, or congruence, you know, so you have to remember which ones are preserving congruence or are preserving similarity. And the similarity is preserved under the dilations, because if you think about it, the dilation is an enlargement or a reduction, and so that is going to change its size. Okay, so the way that I'm looking at this one is that here are my coordinates, J and K. They've kind of started us out with those. And that's going to be corresponding to, J is going to correspond to point A. And K corresponds to point B, and where I'm getting that information is right up here, because the letters all have to, you know, correspond to each other. So this is going to be like a flip, because can you see how J now is below K? So it's a flip, but I have to maintain the similarity. And so I first kind of took a look at the slope of this, just to kind of get an idea how long this line was. It was a matter of going up 3 and over 3, I believe, yeah, up 3 and over 3, but this one goes up 1 and over 1. So to me that tells me that this is a reduction of 1/3 the original size of that park. So that's going to help me probably solve this problem. The next idea I have for this is probably to just go ahead and start plotting these points and seeing if it's a possibility. So I'm going to go ahead and start by plotting the first answer choice, which is 4, 4, and 4, 3, which kind of looks like that shape would be similar to that of Granite Park, but I have to remember that because they set me up this way, that this actually has to be a flip of some sort. So I don't think that's going to do it. If I use the fact that this is actually a flip, I could probably kind of draw it. I'm going to do purple because I can't get rid of my green for some reason. It won't let me erase. But that's going to make it look like something like this is what it's actually going to look like. So if I look at that, at 8, sorry. If I look at this, it's going to, the coordinates that would make up the rest are 8, 3 right here and 8, 4. So that's going to correspond to answer choice D. Okay, for sample question number 2, we're doing a 90 degrees clockwise rotation around point A. And all of your rotations are going to be centered on the origin for this test, so you don't have to worry about anything crazy. But when you do that, you're going to have your X and Y become where you reverse them for the 90-degree rotation, but you also negate the Y. So we're asked to find the coordinate of E after a rotation. Well, E has a coordinate of -6, -3, and when I switch them and negate the Y, that becomes 3, -6. So the question is, what is the X coordinate of E? So my answer would be 3.